Okay, last week we did this one, right? We did carbon electrodes, diluted and concentrated and molten. Remember? Do you remember? Okay, so we are going to do a quick recap. Do example one, example two, example three now. Okay, so example one, this is how you do it, like this. Okay, so basically you must have your list already in your brain, either on a piece of paper or in your brain. So dilute sodium chloride means it's an aqueous solution. It has sodium chloride. Does it have water? Yes. So what you need to do is you need to arrange them. Anions present, hydroxide chloride. Cations present, sodium and hydrogen. Write down the half equation in the anode, half equation in cathode, and based on your half equation, what do you see? Okay, based on your half equation, what do you see in the half equation, and then observation? And then also, if you can, write down what's the product and write down the overall over here, overall equation. Okay, now what are the words, keywords that you must take note of? Diluted means there's water. Concentrated, also there's water. Molten, there is no water. Okay, I only want you to do example one, example two, example three. Okay, do now. You should be able to do because we've done the same thing 5 million times last week. Okay, okay, quickly, quickly do, and then we'll go to the next part. Remember not? Can use your list, okay? You can use your list. Doesn't matter as long as you know how to do it. Eventually, you need to memorize your list, of course. Okay? Jonathan, you done? You can refer to last week's notes. You can refer to... Done? One, two, three. Huh? Yeah, do example one, example two, and example three. Do all three. Okay? Okay, so diluted, diluted, you have a choice between hydroxide and chloride. Diluted, who do you choose? Hydroxide. Okay, so the half equation will be this. Remember, how do you know it's this? Because I wrote it for you 5 million times last week. Okay, now observation. You will see what? Oxygen is bubbles. So you will see bubbling, or you can say effervescence. The name of the product is called oxygen. Okay. The other side, sodium and hydrogen, who do you choose? Hydrogen. So the half equation is this. So because this is hydrogen gas, you will also see bubbling. And the product is hydrogen. So basically here got bubbles, there also got bubbles. Okay? The overall equation would be, because both also hydrogen and oxygen, so it's basically water being split apart. Okay, what does molten mean? No water. So there's only sodium chloride. So there's only chloride and sodium. That's it. So molten is easier. Molten only has one of each. You get it now? All right. So anode is chloride. Cathode is sodium. Okay. So observation here, because it's so hot. Remember, molten means it has to be really, really, really hot. So because it's so hot, this will come out as yellow-green gas. Or green-yellow gas also can. Green yellow. Yeah. The color of the gas is greenish yellow. Because chlorine is darker color. Oh. Okay. Can observation for sodium. Okay, remember it's a metal. So it's a metal, right? It's so hot, right? The metal will sink to the bottom. So you will see lobes like globes. So it's shiny gray deposits. So the product is sodium. Here the product is chlorine. Okay, so overall will be what? It's basically the compound sodium chloride broke apart to become sodium and chlorine. Okay, can? You understand? Can? Jonathan? Jai, you okay? Alright, girls, okay? Can? Alright, last one. Example 3. Concentrated sodium chloride. So concentrated will be the same as diluted. You will have sodium, chloride, and water. So anions will be chloride, hydroxide. Cations will be sodium, hydrogen. So remember, when it's concentrated, we choose chloride. Concentrated, choose chloride, bromide, iodide. Okay, so observation will also be bubbling. Okay, product is chlorine. Half equation here, it still choose hydrogen. Observation also bubbling. Product is hydrogen. Okay. This one, the overall a bit more complicated. Okay. You start out with sodium chloride in water. In your solution, you end up with sodium hydroxide. Okay, in the solution, you end up with sodium hydroxide. Okay, so when they ask you what's left in the beaker, you must be able to say sodium hydroxide. All right? Okay, did you all get this correct? Okay, can I move on? Yeah. Yeah, okay, so, Jai, okay? So silver chloride, silver nitrate is special. Okay, what is special about silver nitrate? Doesn't matter whether it's concentrated or diluted. What is special is silver. Silver nitrate, this is still carbon electrodes. Silver is what? No, no, no. The silver ion is unreactive. So transition metal. So when I have my cathode, hydrogen and silver, who do I choose? Silver. Okay. But my anion won't make a difference. Anion, I still choose hydroxide. But teacher, concentrated, yeah. Concentrated doesn't affect nitrate. Concentrated only affects chloride, bromide, iodide. Okay, so based on this, can you do this quickly? What's your observation? What's your product? Because we're going to use this to do the next part. Okay, so today we're going to finish this chapter. Okay, we're going to use this to talk about the next part. Okay, ready? So anode is the same lah. Okay, anode will be the same. Cathode, you choose silver, remember? So silver ion. So silver ion, when it forms silver, it's a metal. You have to remember silver is a metal. So we'll have one coating here. So here, what you will see is you will see a layer of silver. So you will see shiny gray deposits.
So they are all shining gray deposits.
Yeah, or you can say gray deposits don't have.
On the same day.
Yeah, can.
Oh,
Doesn't have to be shiny lah. All right. This one is just bubbling lah. So this one is oxygen, and this one is silver. Okay, can.
yes.
All right. Okay, now all of the ones that we did so far, all the electrodes are made from what? Carbon, right or not? So carbon, whether we use carbon is also known as graphite lah, or platinum, the results will be the same. Platinum or carbon are known as inert electrodes. Inert. Inert means they will not react. Okay, they will not react with any of the chemicals. So they are known as inert electrodes. Either whether I use platinum or carbon, the results I get will be the same. Can you picture this now? Okay, platinum or carbon or graphite lah. Carbon is also graphite, okay? Graphite is another name for the carbon electrodes. Okay, ready? Yeah, can? Okay, now. So now we're going to talk about the difference of using inert and not inert. So if you look at this is the same kind of thing. It's copper 2 sulfate. Is copper also transition metal? So you would expect the same reactions like using silver, correct or not? Okay, I know there's a lot of different ones, but basically they always ask you copper, silver, copper, silver. Now the hardest thing they will ask you is nickel. Okay, so this one is using carbon electrodes. Okay, this is using carbon electrodes, and this one is using copper electrodes. Okay, so example 6 you can do later, but I want you to do example 5 so that we can compare using inert. Okay, this one is using inert electrode as compared to using a reactive electrode. Okay, so this one is inert, this one is reactive. Okay, but this one I will teach you in a while. We finish this first. So this concept is the same as silver. Okay, can? Okay, please do this. Okay, done? Jaren, are you following, Jaren? Jaren, are you there? Yes. Yeah, okay. So, copper sulfate, hydrogen hydroxide. Okay, by now in your sleep also you must be able to know all these ions. You know how when you're in kindergarten you learn the ABC, then they make you write ABCD. This is your new alphabet. Alright, all these charges and ions is your new alphabet. Last time your alphabet is just ABCD. Now your alphabet is a few together and got charges, okay? So please memorize them. Alright? Okay, if at 5 years old you could memorize alphabet, at 16 years old you can memorize ions. Alright? Now, what ions present? Sulfate, hydroxide. Cation ions present? Copper, hydrogen. Half equation doesn't make a difference whether it's diluted or concentrated or carbon or graphite. Carbon or graphite, now we still choose hydroxide. Okay, by now you have written this equation at least 20 times. Please make sure you know how to write in exam. So you will see bubbling and then oxygen. It's a no problem. Okay, the other side, who do you choose? You choose the transition metal. You choose copper. Observation. Okay, here's the thing. Have you done this in school? Did you manage to do this experiment in school? So what happens is actually quite cute. The reaction, right, will form copper here. Copper Copper metal is the same metal that we use to make electrical wires. What is the color of copper metal? The electrical wire is brown, right? But when you make it on the graphite, when it's freshly made, it's actually pink color. At first, it's pink color. Then when you take it out, leave it to the air for a few minutes, then only you turn brown. You understand? So if you write pink deposits or you write brown deposits, they won't minus mark because it will eventually turn brown. But at first, it's a pink deposits. The reason why I write pink deposits is for you to know that when exam write pink deposits, then you'll be thinking so hard. How come got pink color metal one? It's not. It's actually the copper when it's freshly formed. So the product is copper. Okay, now the exam they love to ask you copper 2 sulfate. One extra reason is because copper 2 sulfate has a color. The color of copper 2 sulfate solution is blue. And the reason copper 2 sulfate is blue is because of the copper 2 ions. The more copper 2 ions they are, the more blue it will become. Okay, so let's do the overall equation. You start out with copper 2 sulfate and water. The cathode, you get copper. The anode, you get oxygen. What is left over? This one and this one is chosen to be discharged. Who is left over? Sulfuric acid. Do you understand? So you balance the equation. 2, 2, 2, 2. Everything 2 except oxygen. Okay? So basically, the blue solution of copper sulfate will change to sulfuric acid. What is the color of sulfuric acid? Colorless. So the blue solution turns colorless because copper sulfate becomes sulfuric acid, which is colorless. Can you understand? No, because you don't know it's copper. Observation is what you see. Get it now?
Rachel, so the copper sulfate turns from me color.
Yeah, because sulfuric acid is colorless. So this is an observation that will be different from the one below. Okay, so you understand this concept? So this one is using inert. This one is using carbon. Okay?
Rachel, what's the overall for the previous one?
I didn't write, but I can write for you lah. Okay, are you done with this? I write for the previous one. This one is the silver nitrate. Okay? Can? Okay, done.
Yeah.
Okay, so this one, done. You understand this one? So take a photograph of this, put in your brain. This is when you're using carbon. Now I change to copper. Copper is reactive. Okay, it's still using dilute copper 2 sulfate. It's still blue. The only difference is now I'm using copper electrodes. Okay? My anion is the same. My cation is the same. And my cathode is also the same. The cathode reaction, I still choose copper. The only difference is my observation. Why? So this is copper electrode. Copper electrode is like brown lah. Okay? And then what's happening? More copper is going on the copper. So because of more copper going on the copper looks bigger or smaller? Bigger lah. So the cathode increases in size. Okay? Can you understand?
Yeah.
half equation, this one is different. So this one, right? Sulfate will go to the anode. Hydroxide will go to the anode. And both of them will say, pick me, pick me, pick me. But then copper says, no, I want to react. The size of the cathode increases. Yes, Jaren, the size of the cathode increases. Okay? So what happens is sulfate will not be chosen. Hydroxide will not be chosen. Instead, this is copper metal, right? This copper metal say, I want to react. Okay? So the half equation is exactly terbalik from this. So now, because of that, the metal become ion. So this electrode will become bigger or smaller? Smaller. So the anode size decreases. So here the product is copper ion and here the product is copper.
This one's overall for this.
This one no overall. Yeah. Okay, can you understand this? So one become bigger, one become smaller. All right. Now, where do we use this for? Okay, so this is the same concept happens when I'm using silver. Okay, can you try and do this? Can you try and do this?
Yeah.
Hmm?
I can follow.
Yeah, yeah, sure, sure. You know where it is?
Huh?
You know where it is?
Yeah.
Yeah.
Awesome.
You done? So, silver, nitrate, water. So, cation, anion. So, same lah. Nitrate, sorry. Okay, so the half equation here will be silver. So, the size of the cathode increases. And then the half equation here, yeah, okay. And then here will be silver decided to become silver ion. So the size of the anode decreases. And then here is product is silver ion, here's product is silver. Okay, okay. Now, this solution is colorless. So there will be no color change, nothing. Okay. Now, what if I have a metal spoon? Iron spoon. Now, this iron spoon can rust easily, and this iron spoon is ugly because it's not shiny. It's iron, not just made of pure iron. So, what can I do to make it more pretty and that I can make it rust less easily? We do something called electroplating. Okay, electroplate. Electroplate is to use electrolysis to coat it with a layer. So what are we going to coat it with? Nobody's going to coat it with hydrogen, right? So we coat it with a layer of silver or copper. Now let's say I want to coat it with a layer of silver. I will use this experiment, right? I want you to think carefully. Where do you put the iron spoon? At the anode or at the cathode? Where do you put the iron spoon that you want to electroplate, that you want to cover with a layer of silver? Cathode. Why? Because the cathode is getting bigger. The cathode is this equation. Right or not? Okay, the cathode is this equation. So if I want to electroplate it, put at cathode. And the equation, everything will be exactly the same. So here I can put my iron spoon lah, iron spoon, iron key, whatever. If I put it here, this silver will dissolve, silver ion will stick. It will have a layer of silver on it. Get it? If I want to do for copper sulfate, then I'll just put my spoon on my cathode here. I can use for irons, key, iron spoon, whatever. So they always ask this question. Okay, so can you please write down these notes? Okay, in order to electroplate, put the iron spoon at the cathode. Can I use it for a plastic spoon? Cannot. Why? Plastic cannot conduct electricity. Does iron have anything to do with the reaction? No. Whether I use iron, I use nickel, I use whatever, as long as I put it in the cathode, there will be nothing will happen. Okay? Okay, done? Nana? Alright. Now, the last part we're going to talk about before we do some questions is called hydrogen fuel cell. Hydrogen fuel cell is basically, electric cars. Electric cars run on electricity. And then petroleum cars run on petrol. Right? Why don't I make a fusion of both? That means I make electricity, but I don't have a battery. I have hydrogen as my battery. So if hydrogen burns in oxygen, I will produce water. Right or not? Is this good or bad? Good. because it's a very good fuel, okay, as compared to petroleum. Petroleum is usually a hydrocarbon, that means got hydrogen and carbon lah. And when this burns in in oxygen, what do I produce? For so many problems. I produce carbon monoxide if it's incomplete, but most of the time I produce carbon dioxide. Carbon dioxide is a greenhouse gas. So good or bad? Bad. So the advantage, they will always ask you the advantage. Okay? So the advantage of having a hydrogen oxygen fuel cell is that it is no greenhouse gas produce. You cannot say no pollution, cannot. You can only say no greenhouse gas, you have to be specific. Can you understand?
Yeah.
Can? Okay, how does this look like? So this one looks like this. It's basically like a big giant battery. They separate it and they put an electrolyte in the middle. They won't ask you to draw lah, I'm just showing you lah. And then here they have like wires. Okay, here they pump it full of hydrogen, and here they pump it full of oxygen. Both of it will be pumped and squeezed into liquid form. Okay, so what happens is I force the hydrogen to release electron because of the electrolyte, and I force the oxygen to receive electron. Overall, this equation happens, but I am producing electricity. It produces electricity. And it's the overall equation. Okay, so there's no pollution at all. Now, the advantage is no greenhouse gas. Okay, the disadvantage of using a hydrogen fuel cell, students very funny, they always say it's explosive. Teacher, is explosive. But every petroleum also explosive, what? All fuel is explosive. If the fuel is not explosive, it's a stupid fuel. All fuel has to be explosive. So you cannot say, teacher, is flammable. That's why it's called a fuel. It's a flammable. Now, the problem with hydrogen that petroleum doesn't have is hydrogen is a gas. So is it easy or difficult to transport? Difficult, because it's a gas. So it's difficult to transport and store. So that's the disadvantage. To transport and store. Okay, please write this down. So for this section of your note of the chapter, right? They only ask you this. This is the only thing that they will ask you. All right, ready? Can? Okay, so we're gonna finish this chapter today. Yay! All right, if you're done writing this down, can you please do the questions below? Yeah, I'll go up for you. Questions 1 and 2. It's only two questions, Questions 1 and 2. Okay? Do question 1 and 2 now.
Which is okay.
Yeah, yeah. 1 and 2. There's only, that means basically finish the paper lah. Okay, come, let's do this. Right, ionic half equation for the negative electrode. So this one you must know, If not, I'll sit down and cry, okay? We've done this like 3,000 million times already. Okay? So this one, what do they observe? Remember, this is copper sulfate on carbon. So they will see pink deposits. Remember, negative is cathode. Two other observations. So bubbling at anode, and then blue solution turns colorless. What did you write, Jonathan? Do I want to know? Okay. Friend's 4.5-year-old is playing drums, learning drums. Oh my God, he's 4.5 years old, not a big guy lah. That's the teacher lah. He's sitting down there. He's playing the drum. Small fella is playing the drum. Not bad. A 4.5 years old. The drum set is bigger than him. Okay. What difference will the student observe if at the positive electrode, which is the anode, if the aqueous copper sulfide were replaced with concentrated copper 2 chloride? Copper 2 chloride, you will see yellow bubbles. Huh? No, different. Because they ask you what difference. Because both also bubbling what? Oxygen also bubbling what? Get it?
Charcoal chlorine gas forming.
Cannot. Observation.
Or what?
Observation is what you see, not what you know. There's a difference. Okay, this one is definition. Remember, definition is not what you feel. Definition is the actual answer. Okay, so breakdown of ionic compound in molten or aqueous using electricity.
Just like electrolysis.
Oh yes, sorry. That's electrolyte. Oh, so sorry. This is electrolysis. Wait, excuse me. So that's for electrolysis. Electrolyte is terbalik. Ionic compound in molten or aqueous that can conduct electricity. Sorry.
So then you give master.
Yeah. That can conduct electricity. Okay. This one is for electrolysis, sorry. Okay. Describe the equation if concentrated aqueous potassium bromide. Half equation at the cathode will be hydrogen. Right? Name the product at the anode. Bromine. Okay? Because it's potassium bromide water. So at the anode, bromide, because it's concentrated. So bromide will become bromine, right? At the cathode, hydrogen ion becomes hydrogen gas. What is left over? KOH. They ask you to name potassium hydroxide. Why is this 4 marks? Your equation is 2 marks. This 2 is 1 mark, 1 mark. Okay? Okay?
Yep.
When molten potassium bromide is electrolyzed, name the product at the cathode. Potassium lah. Good. Okay, so during electrolysis of molten nickel 2 iodide, name the type of particle which is in the copper wire. Remember, copper wire is a metal, so electron. Okay, in the ionic compound is ions. Okay, so you want to write nickel or you want to write iodine, it's okay because they ask whichever. So if you want to do nickel, then you do the nickel equation. Eh, If you want to do iodine, then you do the iodide equation. Up to you. Because the question says whichever. Okay, the last question. Sorry, I have to rush off. The last question, can you all do as homework?
Yep.
Can I please do your homework? Please study. If everything okay, next week we start new chapter. Okay? All right. Bye, Jaren.